we are learning multi-signature smart contract on Remix, Ethereum and using Solidity. So first of all you have to search Remix Ethereum org. It's very good IDE for writing smart contracts. We are going to write multi-signature smart contract enabling send ether to an account and calling another contract from one contract. So now you have to see Remix ID. Here is some built-in examples: storage, sol, owner, sol, ballot, sol. Create a new file, name multi signature wallet dot sol. First of all, you have to mention license identifier, then the variant. Here we are using 0.8.0 and the upper variant you have to mention by this. So first of all, start the contract by name contract multi-signature wallet. We have different events: deposit, submit transaction, confirm transaction, revoke confirmation, and execute transaction. For deposit, we have three arguments: sender, amount, and balance. And for submit transaction, we have owner address and transaction ID and index to which we transfer the amount and the amount value and the bytes data. Confirm transaction, for this we have owner address and the transaction ID. Revoke confirmation, before the execution of the transaction you can revoke your transaction. The owner can revoke transaction by the transaction ID and his address. Here is the array of the owners by which we use the mapping function on the address bool and the number of confirmation required. You can set the number of confirmation for this one for the transaction. And here the struct transaction address to uint value and the bytes data bool executed and you need number of confirmations. So again we are using the number of confirmation by transaction ID. We map the owner's address and then is confirmed. So we use this function. We are here to mention how many owners confirmed this transaction. So we fix if we fix 3 out of 5 owners, so must so it must be 3 owners who confirm this transaction, then the transaction will be successful. Here is the array of transaction and here are the different modifiers. Only owner, so only owner can, if we use this modifier in any function, then this will allow only owner to execute this function. Transaction exists for a modifier, it will check if the transaction exists, and if transaction doesn't exist then it will throw error not executed. Modifier, if the transaction is already executed then we have to manage it, we have not to execute it again. And the not confirm, if the transaction is already confirmed then we have to check it Here is the constructor. We have the owners array and the store it in memory, and we can use it here, call data and others. Here is the number of confirmations required to execute this transaction. So owners dot length is greater than 0. It's mean the owner is required. Without owner you cannot uh, continue further with this contract. And again we check invalid number of confirmations. It is also necessary. Number of confirmations required is greater than 0 and a number of confirmation required less than equal to owners dot length. Here is the loop function for which we have checked invalid owner, owner not unique, only one address can be the owner of one address can be the owner at one time, not multiple times. So here we initialize with all the owners with true and push in the array of the owners. Number of confirmation you can when you execute this contract you can set how many number of confirmations and receive external payable, and we execute the event emitting the event message or sender message dot value and address this dot balance. Payable function is basically the keyword payable allows someone to send ether to a contract and run code to account for this deposit. Here is the simple function for the deposit. When we deploy the contract, then we have to deposit some ethers to this contract. Function submit transaction address to unit value bytes memory data and the public only owner. First transaction has the id 0, so we have to push the transactions in the transaction array and using the struct method. First we initialize by false because the transaction is not still executed, and number of confirmation we set in the start is 0. And then emitting the event submit transaction, then the confirm transaction having the of the transaction. Here we store the transaction in storage transaction transactions t underscore tx index, and we increment the number of confirmation, and then we true this confirmation and emitting the confirm transaction event, and then finally we execute the transaction. Here is also three modifiers and transaction storage transaction transactions underscore tx index. If transaction dot number of confirmation is greater than equal to number of confirmations required, then cannot execute the transaction. It's basically the less than, not greater than. If the transaction dot number of confirmation is less than or equal to number of confirmations required, then cannot execute transaction. Transactions dot executed is equal to true, and here we call the arbitrary function and we initialize it bool success. Transaction dot to dot call value, here is this value we set, and the transaction data. Here we check if it returns true, then the transaction is executed successfully, and if false then the transaction is failed, and finally emitting the execute transaction event. Here is the revoke confirmation. We can revoke the transaction if we do not want to execute our transaction, and we can revoke the confirmation before the execution. Here some get a return function, only we public view we can only view this function. These returning the owners and the transactions length and the transaction data. Here is the complete data of the transaction. So we compile this first After compiling error variant, solidity variant, so we can change it by this and compile it again. It will take some time. Now the our smart contract is compiled successfully. Now we deploy it, and before deploying we have to send it to parameters. First the owners list and the number of confirmations required. So I already write the here the number of owners list, so copy from here and then I set the number of confirmations required is to transact, and our smart contract is deployed successfully, you can see, and you can see here in the log our smart contract is deployed successfully. Here is the owners list and the number of confirmation. So first of all we have to send some ethers to this contract. So I choose ether and then deposit. You can see here is the balance of our contract is 10th ether, and now we submit the transaction. Here you can choose any address, so I will pick the address last one and copy, and then again go to first one. Here is I choose the address and then value the amount send, so I want to send one ether, so I will write here. You can copy value from here and copy, and the number of bytes, it's mean data, you can write 0x00 and transact, and you can see our transaction is executed successfully. You can see it here by writing the transaction 0, and here is the detail of the transaction address to which we send 0. So first of all we have to we require two confirmations, so here we confirm and you can check. Here is the confirmation one, and we confirm it by another owner again. Here we have the two confirmations completed. You can again check it. Here is you can see the two confirmations. Now we can execute our transaction. So for executing the transaction, we require the transaction ID. I choose the transaction ID by the length of the number of the transactions. So here is 0 and 1, and then execute the transaction. It will give the error, so I think it's 0. Now you can see our transaction is executed successfully, and here is the complete log. You can see the number of arguments, owners, and transaction index. And then our we cannot revoke it because you already execute. Check, we can check our, here you can see it will give us a error. Yes, it will give us a error, transaction already executed. So you can check the number of owners from here and get transaction is confirmed or not, is owner or not, and the owners. Here is the complete multi-signature wallet. You can use it on the Web3 by connecting, by using truffle or hard hat, and then connect the smart contract with your web app, and then you can connect MetaMask wallet or other wallet and complete execute your Web3.